Session 11, Cycle Time. Cycle time is the time it takes for inputs to become outputs. For a production process, if raw material is input into the process at 8 a.m. and the first unit of output from that raw material comes out at 12 p.m., the cycle time of the process is 4 hours. Reducing cycle time is not about pushing the process operators to work harder and faster. It's about improving the processes to make them more streamlined and more reliable. Reducing cycle time can increase throughput in sales, reduce in-process inventory, increase on-time performance, and reduce labor cost, increasing profits, cash flow, and return on investment. Reducing cycle time is often the easiest and quickest way to improve an operation's profits and cash flow. Cycle time can be broken down into 4 components: processing time, queue time, setup time, and downtime. Processing time is the time spent modifying or adding value to inputs. Queue time is the time in-process inventory sits idle waiting to be processed. Setup time is the time a process is idle while being readied for processing. Downtime is the time a process is idle due to problems such as equipment failures. The process formula can be used to calculate cycle time. The formula states that cycle time equals in-process inventory divided by throughput. In-process inventory is the quantity of inventory that is within the process. Throughput is the amount of output a process creates during a period of time. In this example, there are 40 chairs in process at various stages of completion. Throughput is 10 chairs per hour. So the cycle time is 40 chairs divided by 10 chairs per hour, or 4 hours. Anyone who works with processes should know this formula well. The formula is useful for spotting opportunities to reduce cycle time. For example, the process formula shows us that reducing in-process inventory by reducing batch size will reduce cycle time. The formula also shows that whenever cycle time is improved, throughput or inventory will be improved as well. The formula is also useful for finding ways to increase throughput, as we will see later when we discuss throughput. In class exercise 14, the operators will use the process formula to calculate cycle time for a process. Have each operator count the units of inventory in production within the process they flowcharted in exercises 2 and 3. Select the first material component input into the process, and then count the quantity of the component present throughout the process. Count all of the inventory that is within the process area, even inventory set off to the side to be processed later. Take note of how much inventory is within process steps being modified and how much of the inventory is sitting waiting for the next process step. This information will be used later for class exercise 27. What is the daily or hourly throughput for the same process? Divide the units in production by the throughput to get the cycle time. The calculation can be done using any time measurement: seconds, minutes, hours, days, months, etc. Which one is best depends on the situation. For class exercise 15, the operators will calculate the cycle time for an entire work cell. They will count all the units of production within a work cell and divide by the throughput for the work cell. Start a run chart for work cell cycle time and update monthly. Can you combine class exercises 14 and 15? Sure. In class exercise 14, some of the inventory was counted. For class exercise 15, count the inventory that wasn't counted in exercise 14 and add to the inventory counted in exercise 14. In session 12, we will look at the value-adding component of cycle time.